Hello guys, today we're gonna look at Leetcode problems 1268 search suggestion system. Given an array of strings, products, and string search word, we want to design a system that suggests most 3 product names from products after each character of search word is typed. Suggested products should have common prefix with the search word. If there are more than 3 products with a common prefix, return the 3 lexicographically minimums products. Return a list of lists of the suggested products after each character of search word is typed. So what this means is that if we have these kind of products like string array, the 3 words will be the search suggested word for M, and these 3 will be search suggested word for MO, and these 2 for MOU, because nothing else has MOU prefix other than these 2 words, and MOUS, MOUSE. So given that, let's think about how we're gonna solve this. So we're definitely gonna have a loop iterating by each character and search inside these. So I'm talking about the brute force solution right now, which will have these 3 prefixes, or 4 or 5, whatever prefixes we have inside the products word. For better complexity, we can actually use the previous suggestion word to iterate. So what that means is that if we have something like starting with C or D, we can first iterate M, and we cannot include that in our suggestion list. So with that said, let's actually start. For character in search word, we're gonna let's actually use I, like index in length in range of length of search word, because we want to use indexes. And after this, we're going to make suggest into an empty list, and we're gonna iterate. So let's actually make this suggest an empty list even before suggest equals empty list, and after that suggest if, and then we would also have to have a for loop for products, and we would say search if search word, the prefix of it, so starting from 0 to I, which would be the syntax, is equals to products element, and we're going to select the same prefix. Then we're gonna add this to suggest. So how about just making this as products, and we're just going to do, if this is not in suggest, we're gonna pop this out. I think this works. Dot pop and then J, and we're gonna have an output array as in list, empty list, and after we're done, we're gonna append the suggest but we're gonna only put 3 of them, and after that we want to test if this works, so we're going to do output and return output, and let's run code. This is not working. Products. Okay, I'm going to use suggest here. List out of index. Is it because of the J or I? Not so sure about this. Line 7. So this should not be a problem. And should this be a problem? Is it because of the J? I don't think it's because of the J. I think it's, yeah, it should be because of the J, because it won't have that much. It's popping it. So if we have like 5 elements and then we pop like the 2 in the between, so popping wouldn't work. We would have to add it. Okay, got it. So that means we don't have a choice but to have suggest into an empty array and put whatever is inside. No, actually we don't have to do that. We can just use a while loop, right? Yeah, we can definitely use a while loop. While J equals 0, J is smaller than length of suggest, and if, okay, let's see if this works, and then we would have to do J plus equals 1, or else it will have an infinite loop, and we have a wrong answer. output. Mobile mouse money pot. Okay, nice. The only thing here is that we should sort this. So we can sort this, suggest sort. But it doesn't work. Mobile money pot monitor. This is right, mobile money pot monitor. Okay, so let's actually see if this pop thing works. It's kind of working. How about here? So it's having mobile mouse. Why is MoneyPot here? It should not be here. Why is it not popped out? So let's see. So so let's actually like forget about optimization and just do the brute force way, and then we can do the optimization. Suggest equals this, and if this is equals to this, we're gonna add it. So just dot append products products J, and we don't need this. We need this and this products. So this will be really inefficient. We'll just erase these all just to make it more cleaner. But we definitely need this. And let's see. It works. And what if we submit it? It works, but it's really slow. So let's actually see the runtime of this. It should be let's say the products have like M items and the search word has N characters. So what this is doing is we have a first for loop here, which is going to be O of N times, and we have a for loop here also, which will be going to be M, and we are also comparing the prefixes, which is also gonna be n. And we are sorting here, and the sorting would be, let's say the suggest has an m inside here, so it's gonna be like m log m, something like this. So this is like so inefficient, see? So a really quick way to optimize this is that we can actually do sorting even before, like we can just do products dot sort outside of it, and then we can just not do this. I'm pretty sure it'll work. Products dot sort. This is not working? Oh. Yeah, it works, and it's a little bit it's a little bit better, but it's not that better. So now we have, like, let's actually look at the runtime of it. It's O of m log m plus n times m, and we are actually comparing the prefixes inside it. So the other thing we can do is that we can not like compare the whole prefix, but we can just compare one character. So if that character, but to do that we should have the suggestion list to carry on. So let's actually do that. So first, the suggestion list is going to be products, and let's actually do for j in range of length of suggestion list, and if we're going to pop it, but pop it based on not index but with the string itself. So it would be if search word of I is equals to suggestion list j I not equals, then we're gonna get rid from, actually we can actually then we will get rid of the suggestion list dot pop suggestion list j. This won't work. I think we should do not this, but for word in suggestion list so that we can just pop the word here. And after that, if it works, we can add this to suggest.append word. Let's see if this works. String object cannot be interpreted as an integer. Oh, so pop needs pop needs an integer. Okay, got it. If you need an integer, I can give you an integer. Suggestion list dot index word, and then I can give you this. How is that? So oh, why are we appending this to suggest when it's not? We should not do this, right? Yes. So after this, we will just make suggest to suggestion list. And let's see. Mobile moneypot monitor. Mobile moneypot monitor. Moneypot mousepad. Mousepad. So what's actually happening here? Let's actually print suggestion list. Mobile moneypot. Why is moneypot here? So 0, 1, 2. We have popped out moneypot. Okay, I think we need more print statements. Mobile moneypot 0 mobile is popped out. 1 monitor is popped out. Oh, I see what's happening. So after 0 is popped out, moneypot becomes 1. So I guess this is not a really good way to pop things out, I would say. So I would say we can have subtract list, and we can add everything inside subtract. and after this for loop we can suggestion subtract this. Would this work? Subtract is not defined. Unsupported operand type. Is there subtract list? Is there a remove? Maybe. X not in list. What? Okay. Difference between two lists. There should be a way to subtract. We could do a for loop, another for loop for element in subtract. If, of course, it's in suggestion list. It's suggestion list dot remove element. Huh. So this works. Where's this print statements come from? Yeah. And if I submit this, it's a runtime error. String index out of range. Oh, what is this? Okay. I'm actually surprised why this error did not come in so early. So this means that word is, oh, so okay, so the word should be smaller than the search word. So I would say A, B, C, D, E, F, and then what happens? Like, I don't think it should be inside, or the length of word is smaller than length of search word. Or yeah, let's say I is 5 and the length of word is 5. Or I is 10 and the length of word is like 5. So yeah, this should be right. And we should also have this. And let's actually try this. First, let's try this. And it works. We're gonna try this. It works. Output except expected, and we see a lot of runtime improvement, faster than 70%. I mean, so let's actually calculate this runtime. So we're first sorting this, which should be m log m, and so nm, this was also n, right? Yeah, so it was like n squared m, but now we are just doing like m log m, and we have to do nm, n times m, but we're not like, this is different. Like, we're not comparing the whole prefix of it, and we're just comparing just one character, and we're taking care of the edge case by if the word is smaller than the search word, so then it doesn't have the same prefix, so it wouldn't be on the suggestion list. So this has been 30 minutes. It's pretty tough one, and I hope you guys learned something from it. Bye.